Welcome to the course Design of Machine Elements. In this lecture, we are discussing about stresses in screwed fastening due to external forces. In the last few classes, we have discussed about the stresses induced in a screwed fastening due to initial tightening load. Now, we can determine the stresses induced in a screwed fastening due to external forces. So, consider this figure. You can see an electric motor, and on the top of the electric motor you can see an eye bolt. So this is the expanded view of the eye bolt. This is the eye bolt. So in an eye bolt there is a threaded portion. This threaded portion will be inserted into the body of the electric motor. So what is the purpose of this eye bolt? This eye bolt is used for lifting the electric motor. So suppose if this electric motor is having a weight, suppose it is having a weight of 100 kilogram force. Now if you are lifting this electric motor with the help of this eye bolt, the weight of this motor will act on this threaded part. So this is an external force. So normally this eye bolt is used for lifting electric motors or generators or other such type of machines. So this eye bolt is attached to the body of this electric motor with the help of this threaded portion. So when we are lifting this electric motor using this eye bolt, sometimes we are using a hook. So, the hook will be inserted through this eye bolt and we will lift the electric motor. So at that time the all weight of this electric motor will act on this threaded portion. So that is an external force. So here you can see a cylinder used in a steam engine or a cylinder used to store steam. Okay. So at the both ends the cylinder is covered with a end plates. So these end plates are attached to the cylinder body with the help of this nut and bolt arrangement. So these are all threaded members. So what is the external force acting on this threaded member? So steam pressure is acting on the surface of this cylinder. So the steam pressure is acting as an external force. So in this case the total steam the total pressure force is shared by this n number of bolts. So here there are more than one number of bolts. So the total load will be shared by all the bolts. So but in the previous case, in this case the total load is acting on this single bolt. Only one bolt is attached to the body of this electric motor. So the entire weight or entire external load is acting on the single bolt. But in this case the external load or the force due to the steam pressure is acting as is carried by this 10 or 12 number of bolts. Now we can classify the stresses induced in a threaded fastener into two types. First one is a tensile stress and other one is a shear stress. So due to external forces there may be tensile stress as well as shear stress induced in a threaded member or a bolt. Now we can check how to calculate the induced tensile stress in a threaded member. So consider this figure. So when we are using this eye bolt for lifting this electric motor, the weight of the electric motor is acting downwards. Okay. So this is the eye bolt. The eye bolt is attached to the body of the electric motor. So when we are using this eye bolt for lifting the electric motor is using some hooks. The weight of the electric motor, I am denoting it as W. The weight W is acting along the axis of this bolt. This is the axis of the bolt. Along the axis of the bolt the weight is acting. So due to this axial external force there will be induced tensile stress. Now we can check what is the formula that can be used for finding this induced tensile stress. So induced tensile stress is denoted as sigma T. Sigma T is equal to external load divided by area of cross section of the threaded portion. So external load I am denoting as P, and area of cross section, generally the threaded member will be in circular in cross section, so which is equal to pi by 4 dc square, where dc, this dc is core diameter or root diameter. So we have already discussed what is meant by D and DC. Okay, the core diameter or root diameter of the bolt. Now, suppose we have a bolt, and that bolt will be made up of a particular material, for example, mild steel or any other alloy steel, etc. So, for a particular material, there will be an allowable tensile stress. What is meant by allowable tensile stress? Allowable tensile stress is the maximum tensile stress that can be induced in a material without failure. Okay. So, if sigma T is the allowable tensile stress and DC is the core diameter, then what will be the maximum external load that can be taken up by a bolt? That is given as P equal to pi by 4 DC square into sigma T. That means this pi by 4 DC square is area of cross section, and sigma T is the permissible tensile stress. That is, if we know the value of external load and area of cross section of the bolt, we can calculate the induced tensile stress sigma T. Otherwise, if we know the material of the bolt, so from the material specification we can determine or we can identify what is the permissible tensile stress, what is the allowable value of tensile stress, and if we know the diameter of the bolt, we can find the cross sectional area. Then we can calculate what will be the maximum external load that can be applied on that bolt. Now, so here you can see that there is a eye bolt, and this eye bolt is having a DC or core diameter. Suppose it is 12 mm. Now, if we know the value of allowable tensile stress of this material, if you know the value of allowable tensile stress of this material sigma T, what we can do, we can calculate what should be the maximum load W that can be applied on this eye bolt. So what should the maximum weight that can be lifted by this eye bolt, so that the induced tensile stress should not exceed the permissible value. So I will find that weight of the motor, maximum weight of the motor that can be lifted using this eye bolt. You can use area of cross section pi by 4 dc square into sigma T. Okay, this is the maximum load that can be lifted with the help of this eye bolt. If you are increasing the weight of the motor, then what will happen? The induced tensile stress will increase and the bolt will fail. So in this case, we can see that the total load is shared by more than one number of bolts. Here 10 or 12 bolts are used to carry the force exerted by the steam. Okay, under that condition, we can use this formula. The external load taken by a number of bolts. If there is an n number of bolts, then the maximum load that can be taken by that n number of bolts is P equal to pi by 4 dc square into sigma T into n. Okay, that means if there are 5 bolts, the total load will be shared by these 5 bolts. Suppose 100 Newton force can be carried by 1 bolt. If you are using 5 bolts, then it can carry 500 Newton. If there is only 1 bolt, it can carry 100 Newton. And if there are such 5 bolts are there, then it can carry 500 Newton. So similarly, the total load carried by n number of bolts will be equal to P equal to pi by 4 dc square sigma T into n, where n is the number of bolts. If there is only one bolt, we can use this formula P equal to pi by 4 dc square into sigma t, and if there is more than one bolt, we can use P equal to pi by 4 dc square sigma t into n. So there are some designations. P is the external load applied in Newton. DC is a root or core diameter of the thread in mm, which is equal to 0.84 d. Sigma T is the induced tensile stress or permissible tensile stress of the bolt material in megapascal. Megapascal is also equal to Newton per mm square. And N is the number of bolts resisting the tensile load. So another type of stress acting on a threaded member is a shear stress. So under what condition shear stress will be induced in a threaded member? So you can see that there are two components, 1 and 2. These two components are attached with the help of a nut and bolt arrangement. Suppose if we are if it is acted by an external force in this direction, I am marking it as P. So we are pulling these two plates, and this bolt is resisting the movement of these two plates, because these two plates are connected with the help of this bolt. So when you are applying equal and opposite forces in these two plates, there will be induced shear stress. Okay, so here also force P is acting and a bolt is arranged here. So the force is acting parallel to the cross section of the bolt. So when a shear stress will be induced in a bolt? Shear stress is induced in a bolt when it prevents the relative movement between the parts in the direction normal to the axis of the bolt. That is, here we can see that this is the axis of the bolt. Right? The axis of the bolt. So the applied load is perpendicular to the axis of the load. So under that condition, shear stress will be induced. Here also, if you are applying a force P in these two bolts, the bolt is trying to prevent the motion of these plates perpendicular to the axis of the bolt. The axis will be along this direction, and the motion is perpendicular to the axis of the bolt. The bolt is preventing the motion, so there will be induced shear stress. Okay, in this threaded member. So how we can calculate the induced shear stress? Induced shear stress is denoted by symbol tau. Similar to normal stress or tensile stress, induced shear stress tau is equal to external shear load divided by area of cross section, which is equal to PS. We are denoting the shear load as PS divided by pi by 4 dc square, where dc is the core diameter. Then if we know the material of the bolt, from the tables we can find the allowable shear stress tau, and if we know the diameter of the bolt, we can find the maximum external shear load that can be taken up by a bolt. So it is given as PS is equal to pi by 4 dc square into tau. Suppose we know the material, we can find the allowable shear stress, value of allowable shear stress tau, using the cross sectional area of the bolt. We can find the maximum load that can be taken by that bolt without failure. So this is PS is the maximum shear load that can be taken by a bolt. If you are using more than one number of bolts for carrying the shear load, we are using this formula. PS is equal to pi by 4 dc square into tau into n, where n is the number of bolts. Okay. So the total shear load, external load, is carried by n number of bolts. Under that condition, it can carry more force. Suppose if you are using only one bolt, if n is equal to 1, it may carry 50 Newton. If you are using 5 such bolts, if n is equal to 5, what will be the shear force? What is the maximum force it can carry? It can carry 5 into 50. Total 250 Newton it can carry. So the maximum load taken by a The maximum external shearing load that can be taken by n number of volts is PS is equal to pi by 4 dc square tau into n, where tau is the permissible shear stress. So we have already discussed about this table. These are the sum of the major diameter or the bolts available in market. So these are the M04 is a 0.4 nominal dia, M0.6 0.6 nominal dia. So when we are calculating or when we are identifying a bolt size, we have to choose from this data. Suppose when we are calculated and we have determined the bolt size as 1.1 mm, and we have to check in the table whether such type of bolt is available. A bolt having nominal dia 1.1 mm. No. After 1, it is the value is 1.2. So we will take the bolt size as 1.2 mm. So this table is used for identifying or selecting bolts as per the standard. Now we can discuss a problem. An electric motor weighing 10 kN is lifted by means of an eye bolt which is screwed into the frame of the motor. Find the nominal diameter of the bolt if the tensile stress is not exceed 65 megapascal. So this is a case related to an eye bolt. So you can see in the figure, this is an electric motor and this is the eye bolt. So this eye bolt is used to lift this electric motor. So the weight of the electric motor is given. You have to find the nominal diameter of this eye bolt. So that is our question. What is the other given parameter? The given parameter is when we are lifting this force, lifting this electric motor, the induced tensile stress should not exceed 65 megapascal. So first the weight of the electric motor. First we are noting the given parameters. Weight of the electric motor. Weight of the electric motor, I am denoting it as P. This is an external force. Okay, this is an external force. P equal to 10 kilonewton. That is P equal to 10 kilonewton. That is 10 into 10 raised to 3 Newton. 10 into 10 raised to 3 Newton is the external load. And the nominal diameter, we have to find the nominal diameter of the bolt. That is, we have to find D. D is the nominal dia. The tensile stress should not exceed 65 megapascal. That means permissible tensile stress, denoted as symbol sigma T, is given as 65 megapascal. That is 65 Newton per mm square. So we have the relation between stress and load. The induced tensile stress. So if sigma T is the stress, then sigma T is equal to external load divided by area of cross section. What is external load is P divided by area of cross section is pi by 4 dc square, where this dc is the core diameter. Okay, so which implies what is P? 10 kilonewton. 10 into 10 raised to 3 divided by pi by 4 dc square. So we are using only one eye bolt, so the value of n is 1, is equal to sigma T. What is the sigma T value? Allowable tensile stress is 65 megapascal. 65 megapascal. Okay. So from this, what is dc square? From this expression, you can find dc square is equal to, we are taking dc square to the right side of this equation sign. So 10 into 10 raised to 3 divided by pi by 4 into 60. You will get this value as 195.88. So dc square is 195.88. So dc is equal to square root of 195.88 is equal to 13.995 mm. It is approximately equal to 14 mm. So core diameter DC is equal to 14 mm. So generally a bolt is designated by its nominal diameter or major diameter. So we have a relation between nominal dia and core dia. So this core diameter DC is equal to 0.84 D, where D is the major diameter or nominal dia. So a nominal dia is represented by symbol D is equal to DC divided by 0.84, that is 14 divided by 0.84 is equal to 16.67 mm. Okay. Now we have to check whether the 16.67 is a standard size or not. For that, we will consider this table. So this table illustrates the standard size of all bolts. So 16.67 m, we have M16 is there. After M16 is M18. So we will choose M18 as our bolt size. So the nominal diameter D we will choose as 18 mm. From the table, after 16 mm major diameter, the next major diameter is 18 mm. So we are not using 16.67 mm. We are not using 17 mm. The next standard size is 18 mm. So the answer is D equal to 18 mm. Now we are moving to the next problem. A generator weighing 15 kN is to be provided with an eye bolt in the housing for lifting purpose. Find the size of the bolt if it is made of C40 steel. If the ultimate tensile strength of C40 steel is 600 megapascal and the factor of safety is 6. So this problem is similar to the previous one. Here also we have to find the size of the eye bolt. Size of the eye bolt means you have to find the nominal diameter. You have to find the nominal diameter of the eye bolt. So the given parameters are external load acting on the eye bolt. external load on the bolt. External load on the bolt is equal to weight of generator. External load on the bolt is equal to weight of generator, which is equal to 15 kilonewton. 15 into 10 raised to 3 Newton. The external load. Now we are using one eyeball for lifting this generator. We have to find the size of this eyeball. The bolt is made up of C40 steel. The bolt is made up of steel, C40 steel. The ultimate tensile strength of the bolt is 600 megapascal. Ultimate tensile strength of this C40 steel is, I am denoting as sigma ultimate tensile strength, which is equal to 600 megapascal. This is the ultimate tensile strength of this material. And factor of safety is 6. Factor of safety is 6. Okay. Now we have to find the size of the bolt. So we have to, from this given data, first we have to find the permissible tensile strength of the material. So we have a definition for factor of safety. Factor of safety is equal to ultimate stress divided by permissible stress. So permissible tensile stress, sigma T is equal to ultimate stress is 600 megapascal divided by factor of safety is 6, which is equal to 100 megapascal or 100 Newton per mm square. Now we have the formula sigma T induced or principal tensile stress is equal to P divided by pi by 4 dc square, which is equal to, what is P? P is the external load, 15 into 10 raised to 3 Newton divided by pi by 4 into dc square. So we have dc square is equal to 15 into 10 raised to 3 divided by pi by 4 into sigma T. What is sigma T? The value of sigma T we have obtained as 100 Newton per mm square. 100. So the answer is 190.986. DC square is 190.986. So from this DC we will find root of 190.986 will get 13.82 mm. This is the core diameter. So we have a relation between major diameter and core diameter. So we have to find the size of the bolt. The size of the bolt is generally represented by its nominal diameter or major diameter. So we have nominal dia or major dia, nominal dia of bolt D is equal to DC divided by 0.84 equal to 13.82 divided by 0.84. You will get the answer as 16.45 mm. 16.45 mm. D is equal to, you will get the answer 16.45 mm. So again, we have to check whether there is a standard bolt available in this dimension 16.45 mm. So we are checking with that table. So in this table, after 16, there is the bolt size is M18. So we have to choose the bolt size as M18. That is a bolt with a nominal diameter 18 mm. So we are choosing D as 18 mm. The major diameter size of the bolt as 18 mm. So size of the bolt D equal to 18 mm. So in the last two problems, we have discussed how to calculate the bolt size when it is subjected to an external load. So we will do similar type of problems in the coming classes. Okay, thank you.